In this experiment, we developed and assessed the comparative qualities of two materials for tissue engineering scaffold applications for bone tissue engineering. The two materials were a pure gelatin and then a gelatin beta TCP composite material. Gelatin has good biocompatibility and beta TCP has good mechanical strength, so combining those two seemed like we hypothesized that this would result in a superior material based on the mechanical properties like compressive moduli, or increased compressive moduli, better degradation rates, and improved cell proliferation rates, the ability of the cells to proliferate into the scaffold. So we created these scaffolds through a freeze drying process that resulted in porous scaffold, solid porous scaffolds. You can see here the composite scaffold has large pores, large enough for cells to infiltrate, whereas the gelatin scaffold has no pores. The scaffolds were then measured, the cross-sectional area was taken, and they were tested compressively to obtain these stress-strain relationships and mean compressive moduli of the materials. The blue is the composite stress-strain relationship, and the red is the pristine gelatin. And you can see that the compressive modulus and compressive strength of the composite material is far greater than that for the gelatin. After doing that test, we masked the scaffolds and then allowed them to degrade for a period of 7 days in solution. We hoped to observe a degradation rate, but because the swelling is the dominating factor for the first few days or weeks, it was difficult to determine what the degradation rate is as the swelling was the dominating factor. So in this graph you can see 3 to 4% swelling rate rather than degradation. So in order to properly get a degradation rate, we need a longer test. After that, pre-osteoblast cells were seeded onto the scaffold, and cell proliferability was observed after 7 days. It was observed that the composite scaffold had 6 times the number of cells, whereas the gelatin scaffold had just 2 times. So that's a 3 times difference in favor of the composite. In conclusion, although we would require a lengthier test for determining the degradation rates comparatively, we safely determined that the composite scaffold is a superior material in terms of compressive modulus and cell proliferability than the gelatin scaffold. This is the main finding of our study.